Hello guys, welcome back to our channel Apna Tutors. So today we are going to do more questions from exercise 1.2. We are again going to do similar topics question like 1 and on 2. And you can expect some question related to 1 and on 2 in your exams in 3 to 5 marks. So let's start without wasting much time. So we are in third question, right? So what is third question? You should know various types of function. I think you should have studied in class 11th various types of functions like greatest integer function, modulus function, step function, and some more are also there like fraction function. You should have knowledge about this all. Okay, so what is question 3? Prove that the greatest integer function f from R to R given by f of x equals to greatest integer function is neither 1 nor onto, where box denotes the greatest integer function less than or equals to x. Okay, so still I will give you some idea for greatest integer function. Suppose I am taking x as 1.2, then what should be the greatest integer function of 1.2? It will be greatest integer less than or equals to 1.2. So it will be 1. Now if I take a f of 2, so greatest integer less than or equals to 2 is 2 because 2 is itself an integer. Okay, so this is the definition of greatest integer function. Okay, so now we have to show it is not 1 and it is not onto. First of all, not 1. When we say 1, for every arbitrary x1, x2, if we are having f of x1 equals to f of x2, then we should get x1 equals to x2. Then we say it is 1. Then to show that it is not 1, we should find one pair of x1, x2 such that f of x1 equals to f of x2, but x1 is not equals to x2. Okay, so what can we take? What we want, f of x1 equals to f of x2, but x1 not equals to x2. So we should like this a property like this. Suppose f of 1.2 is 1, and what will be f of 1? It will also be 1, right? So we are having two different points, but image is same. So take x1 equals to 1.2 and x2 equals to 1. Then f of x1 equals to 1, which is equals to f of x2, which shows that x1 is not equals to x2, which shows that our function is not 1 because for two different points we are having the same images, which implies f is not 1. Okay, so 1 is done. Let's move to onto. Why it is not onto? For onto, what we need, not onto what we'll need, we should find one point in codomain whose there does not exist any x whose image is that point in codomain. So first of all, what is range of these functions? These functions are taking always integer point, right? Only integers. So if I take point other from integer, of course it will not have any pre-image, right? So take y equals to 1.2. So that does not exist any x belongs to R such that f of x, you should be aware of this sign. Okay, this is such that, sign for such that, and this is sign for there exist. That does not exist x belongs to R such that f of x equals to 1.2. You will ask why. So suppose such x exists, then f of x will be greatest integer function of x will be integer. But so what we are taking, suppose such x is, that means f of x equals to y, which implies y equals to greatest integer function of x. But y does not belongs to integer, hence such x can't be exist, because if such x exists, then our y will be integer, but we are taking y as non-integer. So this implies f is not onto. because we had found one point from codomain whose that does not exist any pre-image, because if function is onto, there should exist some pre-image, but here this point is not having any pre-image, so this function is not onto. So we are done with this question. We had shown it is not 1 1 and it is neither 1 1 nor onto. So let's move to next question. Next question is, so that the modulus function, now you should aware of modulus function also. Maybe I had in first exercise I had told you what is modulus function. It takes the positive image of the point. That is, if I am taking x as 1.2, then sorry, minus 1.2, then f of x, I am liking 1.2 very much, then f of x will be positive side of 1 minus 1.2, that is 1.2. Okay, so this is how modulus function is defined. It always take the positive number. Okay, so we have to show this is neither 1 1 or not on nor on 2. So first let's show not 1 1. So for that again we have to find some pair for which image is same but their 2 points are different. So take x1 equals to minus 1 and x2 equals to 1. Then f of x1 will be 1. Also f of x2 will be 1, because f of x2 will be it is already 1, it is already positive, so it will give that image only, that point only, and f of x1 will be 1, but 2 points are different, but x1 not equals to x2, which implies f is not 1 1. I am giving you one task. You should find the how graph of mod x will look. You should try it. You should not just see anywhere, just try how it will look. Okay, so next we should show it is not onto. So we should find one point in codomain whose pre-image does not exist. So again we should first look at into property of modulus function. What is its range? Its range is it takes only positive side, right? So it takes only positive real side. So if we take negative number, its pre-image will not exist, not onto. So take y equals to minus 1.2. So that does not exist. X belongs to R such that f of x equals to minus 1.2. You should give reason, okay, why it will so. You should give proper reason, the way which we did in first part. So this will give function is not onto. F is not onto. So we are done with fourth question also. So let's keep it till this much in this video. In next video we will do more questions. So till there, keep practicing, keep working hard. Have a good day.